Okay, so in today's class, I will be talking about migration in fishes. So, migration is very important and interesting behavioral phenomenon shown by many animals. And migration in fishes is as important as migration in other animals. And we know that migration happens for multiple regions. Sometimes it is for spawning purpose, means for reproduction. Other times it is for feeding purpose, or sometimes it is for avoiding unfavorable conditions. Okay, and the migration is controlled by both endogenous and exogenous factors. So sometimes there are hormones which regulate, some chemicals in the body which regulate the migration, the route of migration, and the process of migration, the duration of migration. Other times there are some external or exogenous factors like physical factors, say for instance temperature or pH of the water, or other factors, physical factors that regulate and affect the migration. So let's see what is migration. So seasonal movement of animals from one region to another is the simplest definition of migration. Or we can say that it is a movement in fishes from one habitat to another for the purpose of feeding or for reproduction, which is also called spawning, or to escape weather extremes or uh, extreme weathers, or in search of shelter is called migration. And many types of fish migrate on a regular basis on time scale ranging from daily to annually, or perhaps longer than that. They take more time than 1 year for migration, in completion of migration. They travel over distances ranging from few meters to thousands of kilometers according to need of the migration. So there are some basic terms which are used in migration in fishes or during migration when we study migration in fishes. So the first term is shoaling. So when a large number of fishes come together and move socially, it is called shoaling. And the characteristic of shoaling is that in the shoaling group, it includes fishes of different sizes, and can include mixed species and subgroups as well. But in this behavioral pattern, they do not form a particular shape. They come together, form a group comprising of different species, members of different size. They move together, but they not follow a pattern or a shape. And the second term is schooling. So what happens in schooling? Sometimes migrating fishes exhibit high degree of coordination in their movements and carry out synchronized maneuvers. What is maneuvers? A movement or series of moves requiring skill and care. And why do they do that? To produce different types of shapes is called schooling. So in schooling, number of numerous fishes come together to form a distinct shape, and well coordinated movement they show in schooling, and it is seen in some fishes like tunas and sardines. Let's see what are the types of migration. So as in the definition, we discuss that migration may happen for a number of regions, and it may last for few minutes to more than a year. So daily migration mainly for food gathering, annually migration mainly for reproduction in search of better habitat for spawning purpose, where availability of food and concentration of oxygen is higher, or which or then higher and required for spawning, and temperature is suitable, so they show annual migration. Then generational migration. So parent migrate to release egg, and they die over there during this process. Then juvenile migration, it involves larval stages of fishes which hatch in spawning grounds and migrate long distances to reach the feeding habits. of their parents. So this kind of migration is shown by juvenile or the fries or the larval forms. Then recruitment migration. It takes place when large number of larvae move from nursery habitat to habitat of adults. So they are going back to the habitat of their adults. Then feeding or elemental migration. The young ones migrate to the home in search of food. That means it takes place in fishes for feeding, like salmon, cod, and swordfish migrate for food. And remember that the type of migration given on this slide may vary in different source or different text or material provided for migration in fishes, because sometimes many authors or many teachers use different terms or synonyms for same terms. Then spawning or gametic migration, it takes place in breeding seasons in those fishes which have spawning grounds for far away from the feeding places, and this kind of migration is seen in eels and salmons and other fishes. Then seasonal or climatic migration. It takes place in fishes that inhabits Arctic areas where in summer climate is conducive and food abundant, but as winter approaches, temperature fall below zero and food becomes scarce. Hence, fishes must migrate towards subtropical and tropical areas to escape extremes or adverse conditions of weather. Then, denatant migration. If the movement or migration of the fish is with the flow of water or the current, or you can say it is drifting migration. Then, contrary movement. On the contrary, if the fish swims against the current, so the denatant and the contrary movements are opposite to each other. Then osmoregulatory migration is also happen or also seen. Then migration for water and electrolytes balance from sea to fresh water and vice versa is called osmoregulatory migration. And if we see the types of migration on the slide, the fish migration is of following types. So this migration is on the basis of habitat, change in habitat. So Potamodromus means freshwater, Oceanodromus means migration in the ocean or in the brackish water. Then Diadromus migration, it is also called Amphidromus migration. So it is from fresh water to marine water and vice versa, from marine water to fresh water. So the diadromous or amphidromous migration happens to be of two types, catadromous and anadromous. So in catadromous migration, from fresh water to sea water, migration in fishes is called catadromous. Then from sea water to fresh water, migration in fishes is called anadromous migration. This is the video I'm going to show you, by which you will be gaining more information and facts about migration in different species of fishes.
Almost half of the world's population is reliant upon fish as a food source or as a way of making a living. But rising temperatures are changing the oceans and disrupting fish habitats, and carbon taken in from the atmosphere is making the oceans more acidic, affecting the growth and survival of many species. Many fish are being forced to adapt, migrate, or die. The impact upon people who rely on fish for their sustenance and livelihoods will be profound. The ocean covers almost 3/4 of the Earth's surface and acts as a huge temperature store. In spite of this, average sea level temperatures have risen 3 times slower than the air temperature on land. But even slight changes in temperature in certain regions can produce huge shifts in the distribution of life under the water. Many marine animals are capable of short-term adaptation by changing their behavior or physiology. Fin and humpback whales, which can be found from the poles to the equator, have altered their migration patterns over time as a result of warmer waters. But fish that have evolved in less variable polar or tropical temperatures are less able to adapt and are sensitive to even slight changes. And those in equatorial regions are already living close to their upper heat limit. If the ocean surface temperature rises between 2 to 3 degrees Celsius by early next century, equatorial waters could become completely uninhabitable for most shallow water fish currently living there. Those that cannot leave will face local extinction. Whether evolution can keep up with climate change in the long run is unknown. But a mass undersea migration has already been happening for decades. Around the world, both cold water and warm water fish have been heading towards the poles, searching for cooler waters. North Sea cod have moved farther north and gone into deeper territory over the past century as a result of climate change. This has been good news for Greenland's fishermen, but not for those further south. Red mullet used to be a staple Mediterranean catch, but from the mid-1990s started to be seen off the coast of Scotland for the first time in 70 years. Plankton, primary food sources to all sorts of animals, have moved the most out of all marine life. In 2010, researchers sailing off Norway's Svalbard archipelago found tropical plankton from the equator in their nets, a possible preview of climate-induced changes. Where prey moves, predators usually follow, so entire food webs will likely be affected. But not all the changes will be harmful. On current temperature trends, the world will actually start to experience a net increase in biodiversity, as species expand and thrive in new spaces. But by mid-21st century, there will be large losses and local extinctions across tropical regions, resulting in an overall net loss. And while migration can spell survival for the fish able to make the transition, it can also adversely affect the ecosystems of the places they migrate to. Recent expansions have already been causing havoc. Invading tropical fish have been decimating kelp forests off southern Japan, which provide nutrients to local species. Melting ice between the Atlantic and Pacific Oceans is opening up large-scale pathways for species invasions of the size not seen for 3 million years. What effects mass migrations will have upon complex ecosystems in the long term is unknown. But as the tropics experience large-scale losses of species that are not replaced, many will lose the fish they depend on to survive.
Salmon spend years in the ocean and then return to the rivers where they were born. When young, these sockeye salmon had migrated towards the sea in search of food. However, as the day shortens, their instincts impel them to return to their birthplace. Thousands of salmon congregate near the coastline from all over the expansive Pacific Ocean. Then they proceed towards the estuaries of the rivers of Alaska. Their resolve to find their way home when it is time for them to reproduce is one of the most remarkable and mysterious feats of nature. It is believed that the sun and the Earth's magnetic field help them in navigation. The incredible precision of their journey is fascinating. Their bodies have to adjust to the fresh waters as they travel upstream. An amazing adventure beckons them. Not all will be able to complete this journey. Several die of exhaustion and are eaten by scavengers like eels. However, the rapids and waterfalls of the swift-flowing Alaskan rivers provide them with their biggest challenge. The salmon can jump 12 feet up the waterfalls through exceptional effort. They struggle up the waterfall just to encounter a more dangerous adversary, the grizzly bear. These grizzly bears assemble at the rivers, eagerly awaiting the salmon's expected return, and the salmon do not disappoint. For the skilled grizzly, they're an easy meal. The younger bears, though, have a tough time catching the slippery fish. Unfortunately, many salmon lose their lives at this stage. It is caviar for the bears, but the death of these eggs marks an abrupt end to the future of the salmon. Several of them are successful in escaping these predators and continue with their 1,000-mile journey. As the rivers converge and the waters become shallow, their sharp sense of smell guides them to the breeding grounds where they were born. The urge to procreate motivates these fish to overcome the relentless force of the current as they continue on their extraordinary mission. The salmon also become easy targets to aerial predators due to the shallow waters. Just prior to spawning, sockeye salmon undergo striking changes in their color and shape. The male's jaws transform and grow a vicious set of teeth. They have to compete with each other to win the right to the best females. Once paired, the female digs a shallow nest on the riverbed before laying her eggs. The male then fertilizes them. Having mated, finally, thousands of heavily fatigued salmon now perish in these waters. The adventure is over. The sockeye salmon die in... Deep into the Pacific Ocean, minute eel larvae have commenced on a dangerous voyage. Out of the millions who have started this journey, a very small number will reach the rivers of Southeast Australia, 2,000 miles away from their birthplace in the ocean. Only a few will survive this epic swim that takes a whole year, but as they reach the estuaries, many obstacles await. What drives them to travel so far is not yet clear, but their resolve is faultless. As glass eels, they now have short and narrow bodies and must learn to adjust to the fresh waters as they are forced up the rivers by the rising tides. Their journey might end abruptly due to prowling predators. The eels are defenseless and easy targets, so they must wait till dark to continue their trip upstream. The eels are not safe even at this hour, as perches lurk around hunting at night. A fortunate escape. The eels display great resilience against the strength of the flowing waters, but greater challenges lie ahead. The dam is blocking their route. They cannot win over the rushing water, but their urge to reach upstream is so intense that they come out of the water and start climbing the side of the dam. The dam is 5 meters high, and this arduous task may take 3 hours. Being skin breathers, these eels are in danger of drying out. The running waters could wash them back down from the top, forcing them to restart the climb. However, those who manage to succeed continue their voyage upstream and begin to grow. It takes many weeks for the elvers to mature. Their skin turns brown and they feed on worms which are available in abundance. However, they are still hunted by others. Water rats present in these regions are adept at hunting using their powerful webbed feet to catch prey underwater. Escape is improbable. They have traveled far upstream after 6 months of struggle. They reach the lakes along the channel and develop into adults measuring 1 meter. These lakes will be their home for the next 25 years. Fish, crustaceans, and carrion are their source of food here. Remarkably, their journey does not end here. After having lived in the lake for years, these amazing navigators return to their birth grounds in the Pacific, never to be seen again. Finally, they realize their lifelong quest by diving deep down to breed and perish.
Okay, so in this video, you watch three types of migration in fishes: oceanodromous, catadromous, and anadromous migration. And you must have observed in this video that these migration happen mainly for spawning purpose, means reproduction purpose. Okay, and you also observe that there are some fishes who come back to the place where they were born, they took birth, and they die over there after spawning and laying eggs which are fertilized by females. So how spectacular, fantastic, and interesting phenomenon in migration in fishes is seen. And here I'm, uh, you know, stopping this presentation.